Hello, I'm Christine Villanueva, the group leader. Welcome to our final project presentation for IT 105 Information Management. Our system is an e-commerce order management system designed for pastry business. Based on our instructor follow-up feedback, we refine our ERD to clarify relationship and standardize foreign key usage. We also improved normalization and added missing constraints. These adjustments enhance the accuracy of our relational model and ensure data integrity across our database. In this presentation, we'll walk you through the progress we made from weeks 11 to 14, covering schema implementation, data generation, backup and recovery, cloud deployment, and database optimization.
For this week 11, our task as a database architect was to implement the physical schema using the MySQL workbench based on the updated ERD. We created five main tables: the orders, order details, products, users, and payments. Each table includes the primary keys, foreign key constraint, and national values to enforce the data integrity. For example, order details has a foreign key referencing both orders and products, which ensures that no order detail can exist without a corresponding order in a product.
Instead of using Mokaro, we use stored procedures with loops to generate over 100,000 rows of sample data. This allowed us to maintain consistency, especially for foreign key values like user IDs and product IDs. For instance, we ensured that each order had matching details and each payment matched the correct order. We use select count star to verify that each table had the expected number of rows. Then, we ran sample join queries across tables to confirm that relationships were correct and functioning as expected. This large dataset became the basis for our analysis and testing in the next few weeks. Instead
In week 12, we focused on business intelligence and reporting. We wrote SQL queries that provided meaningful insights such as daily order values using group by and sum, top selling products using joins and order by, and monthly sales reports using date underscore format and group by.
We also designed a schema model inside the same e-commerce DB. This involved creating a fact table called order facts and several dimensions tables, like dim products, dim users, dim date, and dim categories. This dimension transforms transactional data into structure ideal for analytics and dashboarding. We also designed a
In week 13, we created a backup of our database using MySQL dump, which generated a .sql file containing our full schema and data. This ensures our data can be restored in case of failure. To simulate recovery, we dropped our local database, then restored it using the same .sql file. We validated the recovery by checking row counts and running select queries to confirm the tables and records were successfully restored. Additionally, we deployed our MySQL database to Railway, a cloud-based platform, and after creating a Railway project and setting up a MySQL plugin, we imported our database backup and successfully connected it with MySQL Workbench. This simulates a real-world cloud deployment scenario. Along with backup and recovery, we also explored how cloud and emerging technologies could shape future growth. In week 13, we created a backup.
For the second part of week 13, we reflected on how emerging database technologies could be integrated into our system. We explored how big data platforms could be used to store customer reviews, product logs, and large volumes of unstructured data. AI tools could help in sales forecasting, product recommendation systems, and customer behavior analysis. These innovations would enhance our database system scalability and intelligence, giving our e-commerce platform a competitive edge.
In week 14, we performed query optimization to improve performance on our 100,000 plus dataset. We selected three previously used by SQ queries that had slower execution time. We ran these queries and used the explain keyword to analyze how MySQL processed them. This revealed performance bottlenecks such as table scans, missing indexes, and inefficient use of selects.
To optimize performance, we first added indexes on frequently filtered and joined columns like product underscore ID, user underscore ID, and order underscore ID. Second, we wrote queries to avoid nested selects and subqueries. Third, replace select with specific fields to reduce overhead. So these optimizations made our query significantly faster and more scalable, preparing the system for real-world usage. We saved both the original and optimized versions in a separate SQL file and documented the explained results before and after. To optimize performance, we
As part of the improvements based on our professor's recommendations, we made several important revisions to our database to make it more realistic and ready for production use. First, in the orders table, we changed the status field from just pending or completed into a more meaningful structure. We removed the status column and added a new column called completed at to clearly record the exact timestamp when the order was successfully completed. Next, for the payments table, instead of using a vague status like pending or failed, we added two new columns: date paid and payment remarks. Date paid now shows when a payment was made, and payment remarks allows us to store specific notes, especially if payment failed, for example, due to a declined card or expired method. We also improved the users table by adding a created at column with randomized timestamp. This simulates real user sign-ups and make the dataset more realistic for analysis. For inventory tracking, we revised the products table by renaming stock quantity to inventory for clearer naming. Additionally, we added real values to this inventory field to reflect actual stock counts after purchases. Finally, we removed the old inventory updated at column and replaced it with a new log timestamp in the inventory logs table to better track when changes in stock happen. These revisions improve the clarity, accuracy, and analysis capabilities of our system, especially when dealing with large datasets and business intelligence reporting. To wrap up, our group successfully built a scalable, secure, and optimized database system tailored to e commerce needs. Through each phase, we applied practical skills in schema design, data analysis, cloud deployment, and performance tuning. We appreciate the guidance of our instructor throughout this journey. If you have any question, we'd be happy to answer them. Thank you for watching our video presentation.